KVL KCL. Then how to apply KVL KCL in electrical circuits. Some rules to remember to apply KVL and KCL. Then we did series and parallel connections. We also saw advantages, disadvantages, and applications of series and parallel connections. We did some examples for series and parallel connections. Okay. So anyone can tell me what are the disadvantages of series connections?
Yes, sir. If one bulb
If break,
diffuse then
One
the
one by one by one.
it's not work.
Yes, anyone can tell me if any correction is there. Then yes, Rajvi.
If many equipments are connected in series and one of them fuses or stops working, then the whole circuit will be broken.
Yes, good. Then second, Sivangi, second disadvantage.
As we apply more number of components in the circuit, the resistance will increase.
Okay,
Greatly increase.
okay. Anyone want to add in disadvantages? Suppose we are connecting electrical appliances of same rated voltage of 230 volt in series, then what will happen? If we are connecting electrical appliances of same rating, uh, like example 230 volt, suppose I have three bulbs that is rated of 230 volt that is connected in series. So what will happen?
So the
Voltage is
supply
divided
voltage
for
will
each.
Yes, supply voltage is just we have 230 volt. So 3 into 230 that becomes 690 volt. So that is not applicable. Okay. So series connection is not applicable for domestic and power wiring connections. Okay. So due to this drawback, where it is applicable?
In decorative lights.
sir
Yes.
for decorative purpose.
Yes,
And
decorative purpose, or you can say low voltage, for low voltage rating, it can be applicable. Or suppose we want to uh, control the fan, so that is done by regulator. So regulator that can be connected in series with fan. Okay. What are the advantages of parallel connections?
power supplied, voltage supplied is equal in all the parallel connection.
Yes, yes. But what will be the difference? Voltage rating is same.
If any one of the
Power
appliance in the connection would went off, but
One,
other would be get affected due to that problem.
just one by one.
Sir,
Yes.
in parallel connection, if there are let us take four appliances are connected in a parallel connection, where
Okay.
if one of the appliances have problem or break in the circuit, the other three won't get affected due to this problem.
Yes. Good. Good. Okay. Then second advantage.
we
Suppose.
can use
It is used
sufficient
in
power.
power supply and domestic use.
Okay. Just I am okay repeating. Just. So major advantage is that electrical appliances that is rated for same voltage, but the due to difference power rating, uh, that we can connect in parallel connection without affecting any other appliances. Okay, so we can switch on and off any electrical appliances without affecting or without damaging to the other appliances. Okay, so due to these advantages, parallel connection is used for domestic as well as power wiring connections. Okay. What is the equivalent resistor equations for series connection? R equivalent is equal to R1 plus R2 plus R3. For parallel connections, equivalent resistor 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In series connections, the equivalent resistance value is greater than the greatest resistance connected in series. In parallel connections, the equivalent resistance is less uh, compared to the least value connected in parallel connections. Okay. Then, uh, then what we did? We did some rules. Okay. Suppose for KVL and KCL, we are traveling positive to negative. Then there is fall in voltage. So it is denoted by negative sign. We are traveling negative to positive. So there is rise in voltage denoted by positive sign. We are moving through resistor. So there is fall in voltage, negative sign. We are moving uh, through resistor in opposite directions. So there is rise in voltage. So it is denoted by positive sign. Okay. Then we did some examples of series and parallel connections. Okay. So according to the knowing of series and parallel, you can convert the diagrams and accordingly you can do the calculations. Okay. So accordingly, whatever you ask, find out the equivalent resistor, unknown resistance, circuit current, voltage, power. So accordingly, you can find out. Okay. Now today we will do some uh, electrical terms. We'll see for second units. Okay, so first one is element. So element, that is, it is a mathematical model of two-terminal electrical device which can be completely characterized by its voltage and current. So you can see this symbols are given. It is called the elements. So it has two terminals are given up down. Okay, so these are the called elements. So some of the elements are dependent sources and some of the are independent sources. So that we discuss in active element and passive element. Okay, so this black colored source are independent source, but this red color source, that is called dependent source. So in circuits, you will be having this both type of independent and dependent sources. So according to this identification of symbol, you can identify this is independent and this is dependent sources. Okay. So, and we also discuss active and passive element. Okay, voltage source, current source, active elements, passive elements, RLC, resistor, inductor, and capacitor. So these are the circuit elements. Networks. So what do you mean by networks? So the interconnection of two or more element called an electrical network. So you can see here in the two or more element. Okay, so here we have number of elements are there. Here this is element. Okay, so this we have number of elements are connected in network. So this whole circuit is called the network. Circuit, if network contains at least one closed path, it is called the electrical circuit. So you can see here in the circuit diagram, it is closed. Okay, the path, all paths are closed. So that is called the circuit. So circuit that needs, suppose I am drawing 5 volt, I am connecting one resistor. So this is called the closed circuit. Okay. This is your R. Active element which is capable of delivering an average power or that is greater than 0, or it can capable of delivering energy or power to the circuit or to the external device. It is called the active element. Passive element capable of receiving power or energy, that is called the passive element. Node, So node and junction generally that is similar, but for the specification, so if node is the point at which two or more elements are connected together, it is called a node. So in circuit diagram, you can see. Just I am erasing this. So anyone can tell me how many nodes are given in the circuit? Nodes means two or more elements connected together. That is called node. Okay, just I am unmuting all. Okay, so this is called A is called node, B is also called node, C is also called node. This is also called node. So we have four nodes A, B, C, D are called nodes. Okay, so where two or more elements are connected. Junction, so junction and node is similar, but in junction, we are considering three or more elements are connected together. Okay, so where more elements are connected, that is called the junctions. So suppose we are considering this B point, that is called the junction. Okay, so where more elements are connected. So this is we are considering junctions. This also we can consider a junction where three elements are connected. Okay. Branch, a section or portion of network or circuit which lies between two junction points is called as branch. Or portion of network or circuit which lies between two junction point is called branch. So here we have branches, this BAD, this you can say this BAD. I'm just erasing. In branch, we can say this is your branch, okay? BAD, this is your also branch. This is also your branch, okay? So BAD, BCD and BD, that is your branch. This is also you can say, okay? Branch means it lies between two junction points. So this you can consider branch, okay? Where elements are connected. Loop, any closed path in a network is called loop. Okay, are you getting what I am telling? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So now you should take care by considering loop and this loop and mesh. Both are different. Okay. Loop means any closed path in a network is called loop. So here anyone can tell me how many loops are here? How many loops are here in circuits?
Three.
Sir, your screen is not visible.
Three.
Four.
Four.
Three.
Four.
Okay, wait. I am.
Six.
So here we have in loop we have uh, B A D, then second uh, B C D, then
Six.
A B C D A, then we have A A A, then or you can say
A, C, D, A.
ACB.
In R6.
ACB. Okay, so these are called the loop. Okay, now mesh, that is it is the most elementary form of loop. and it cannot be further divided into other loops. So that is called a mesh. So tell me, here I have written 4 loops. So how many mesh are there?
3.
Only 3. So which I have to cancel?
ABCD.
ADC.
Yeah, this ABCDA. So your mesh is, it is most elementary form of loop, but it can't be further divided into uh, uh, other loops. Okay, so suppose we are considering this BAD, BCD, this ACB. Okay, and now we are not considering this ABCDA again for the mesh. Okay, so it can't further divided into loop. Okay, so mesh, that is most elementary form of loop, but it can't further divided into loop. Okay, so we have mesh only 3, and in terms of loop we have 4 loops are given in circuit diagram. Anyone having doubt regarding to this mesh and loop?
No, sir.
No, sir.
Okay, good. So just these are the basic terms that you need to remember. You will be asked in definition also, okay, in internal as well as external examinations, so that you have to remember. Just now we are jumping to the star data transformations. Okay, and after that we will do mesh and nodal analysis. So we'll get the idea for the applications of KVL and KCL. Okay, see this is the current divider rule. So that I already discussed. Current divider rule that is applicable in parallel circuits. So you can see here two resistor that is connected in parallel with across supply voltage. So suppose I want to find current I1, then I need to consider opposite branch resistor. So opposite branch resistor, that is R2, okay, or other branch resistor is R2. So I can write here for suppose I want to find I1, then I1 is equal to other branch resistance or opposite branch resistor R2 divided by total resistance in the circuit R1 plus R2 divided by into supply current I. So this is your current divider rule. So suppose I want to find I2, then you need to consider opposite branch resistor or other branch resistor. So suppose I want to find I2, then I have other branch resistor R1 divided by total resistance R1 plus R2 into supply current. Okay, are you getting this current divider rule?
Yes, sir.
Okay, just I am
Yes,
giving.
sir.
Yes, sir.
Okay, I am giving
Yes, sir.
one example. Suppose I am having like this. This is R1, R2, R3, R4. Now I want to apply current divider rule. Then anyone can tell me I1 is equal to
I5 minus I2.
current divider rule. According to current divider rule.
R3 plus R4 divided by R1 plus R2 plus R3 plus R4.
Okay, something missing.
Into IS.
Into
I.
Into I.
IS.
Yes. So this is
Yes.
okay. This is the parallel connections. So I can apply current divider rule. Okay. So I1 is equal to, so suppose I want to find I1, then I need to consider opposite branch resistor. So in opposite, we have R3 and R4 in series connections. So I can write R3 plus R4 divided by total resistance, R1 plus R2 plus R3 plus R4 into IS. I2 is equal to I2 is equal to
R1 plus R2 upon
R1
R1 plus R2
R1
plus
plus
R3 plus
R2
R4 into IS.
plus R,
into IS.
R1 plus R2 plus R3
Plus
plus
R4 into IS.
into IS. So this is your current
Yes.
divider. So you can apply any equations by knowing the relations. You can find out current by according to Ohm's law, by according KCL, IS is equal to I1 plus I2. Okay, by knowing the other parameters, you can also apply current divider rule also for finding currents in the parallel connections. Okay. So this is I1 and I2 for this circuit. Now voltage divider rule that is applicable for series connections. Okay, so voltage divider rule. So V1. So for finding V1, so V1 that is across R1. So I can write for V1, V1 is equal to across R1 divided by total resistance R1 plus R2 into V. Okay, that is your supply voltage. And V2 is equal to, that is across R2 divided by R1 plus R2 into V. So this is the voltage divider rule you can apply for finding this voltages V1, V2, V3, V4. Okay, according to the ask in circuits. Okay, anyone having doubt regarding to this voltage divider rule?
No, sir.
No, sir.
No, sir.
Okay, good. So this is the star delta transformations. Why we are using these star delta transformations? We are to solve complicated networks. To solve complicated network or circuit. Okay, we are doing these star delta transformations. Okay, so that is not done, or that we can't solve by mesh, nodal, or series and parallel connections for complicated networks. So for complicated networks, just we need to use star delta transformations. Okay. So just you need to remember the conversion equations. Okay, so this is your star connections in star. How to identify this is star connection? In star connection, we are getting one common point. Okay, for these all three resistors, we are getting one common point. So this is your star connections. And delta, it is like closed loop. Okay, we haven't any common point for all three resistors. Okay, so this is your star connections and this is your delta connections. Now we are converting the star into delta. So you can write this ABC is given here, RA, RB, RC. So it can be written as RAB, RBC, RCA. Okay, so how we can write into the equations? So that is done by, so RAB that can be write as already mentioned RAB, RBC and RCA resistors. Okay, so you can write for this star to delta conversion, RAB is equal to RA plus RB plus RA RB divided by third resistor RC. For RBC, you can write RB plus RC plus RB into RC, third resistor RA. RCA, RC plus RA plus RC into RA divided by third register RB. Okay, so that just for remembering, just you need you have to remember, if star connection is given, just give the name. You can give ABC, then DCE. So whatever name you are giving, so accordingly you can write the equations. Okay, so for the RAB, you need to write the summation, multiplication, and divided by third resistance. Okay. So is it easy this equations? You have to remember these equations while
Yes.
applying the circuits. Okay, when we are converting star to delta, then you will be having this type of equations, and according to the values are given, so you need to substitute, and you need to get those resistance value.
Sir,
Yes.
in star form, there should be minimum 1 point, or there can be many points, or
No, only 1 point. You need to identify in the circuit which connection is given, star or delta is given. You need to identify first, star or delta is given. So according to that, you need to do the conversion for simplifications. Okay, but if you are just converting star delta, then delta to star, just your calculation becomes complicated. That I will show you in example. Okay, where you will make mistake. So this is a star to delta equation. Now delta to star. In circuit, if delta is given, then you need to convert star for simplification of circuit. So this is the data connections ABC, RAB, RBC, RCA. So that is converting into RA, RB, and RC. So the equation can be written as for RA. So you can see here RA that can be write as RAB into RCA divided by RAB plus RBC plus RCA. So in delta to star, with suppose I want to write the RA equations, then the resistor connected with A, that I need to multiply, and I need to just divide all three resistors. Okay, so for RA, I have two resistors connected, RAB plus RCA. RAB into RCA multiplications divided by summation of all three resistors. For RB, so for B, two resistors are connected, RAB plus RAB into RBC divided by summation of three resistors. And for RC, so for C, I have two resistors connected, that is RBC and into RCA divided by all three resistors summations. Okay, are you getting these equations? So in delta, when you convert into
Yes.
star, so the resistor connected with A, B, and C, so that you can write equation diagonally. Okay, the resistor connected with A, the resistor connected with B, the resistor connected with C. So you need to do multiplications divided by a summation of all three resistors. Okay. In star to delta, what we are doing? Just we are finding RAB, RBC, RCA. So just we are writing RAB, RA plus RB plus RA into RB divided by third resistor. Same for RBC and RCA. Okay. So have you written these equations? Now we are moving to the example.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
you will understand this, you will get easily this by seeing the examples. Okay, this example you can see here. You will see here number of delta. Can you see this here? Number of delta are given. Any star given?
Delta is given.
Yes.
Delta is given.
Yes, number of deltas are given, but here we do not need to use star delta transformations, because this we can solve by series and parallel connections. If you are going for star delta transformations, then your calculation becomes complex. So you can see this, with this we already solved, okay, in previous lecture. So this 100 and 100 series connections, 50 and 50 series connections. Okay, so then it is becomes parallel connection, which is 50 ohm and 100 ohm. Okay, so you can see here this series connection, this series connections. Okay, that is 100, 50. So now this become like this 200 in parallel with 50, 100 parallel with 100. Now your circuit reduced to this. Okay, just we have only this value, this 40 and 56 downward. So our circuit becomes like this 40 and 50. So this is again in series. Now that becomes in parallel with 90. Okay, so this is parallel connections. Again, this is in series connections. Okay, now that becomes parallel with 100. Okay, so this is parallel connections. Now your circuit becomes like this. So this is your equivalent resistor. This is your supply voltage. You can find current I according to Ohm's law, I equal to V by R. So that is your total circuit current 2 ampere. Okay. So sometimes just you need to identify what you have to apply to get the answer easily. Okay. So don't make the calculations complex. Otherwise you will not get the answer, and you will waste your time. Okay, and you will be having in internal for 30 marks you will be having 1 hour, and for the external for 70 marks you will be having only 3 hours. Okay, so suppose you are wasting 1 hour for one example, then just you will not attempt whole question paper. Okay, so that you need to take care. So generally for any example you will be asked which method that you have to apply. So if star delta is asked, then you will be asked using star delta you need to solve this example. Okay, so this already is given. Star delta transformation, determine the resistance between terminal A and B is given in the circuit. Okay, so any delta is given. So already here given. Okay, so this closed path, you can see this is delta here, this is your delta. Okay, this 25 and this 15, that is your delta connections. Now we need to convert into star connections to make circuit simplified way. Okay, so you know the conversion. So suppose this delta is given like this, so you need to convert like this in the circuit. Are you getting this? Suppose
Yes.
according to the circuit connection, you need to set this star to delta conversion. Okay, suppose okay, this is my delta connections. Okay, so generally what we are doing, just we are doing like this. But according to the circuit requirement, you can also convert like this. Okay, this is your star connections. This is similar. Okay, now reverse, this reverse delta is given like this. So you can draw like this. Okay, or you can also draw like this. This is your star connection. One common point is there. Okay, are you getting this? It is
Yes.
Yes, sir.
Sir.
it's not need to draw like this. This is also star connections. Okay, this is also star connections. Okay, sometimes you will be given like this delta. So you can draw like this in the circuit. Okay, sometimes you will be given like this. So you will get like this in conversion. You will get like this. Okay, so this is your star. So according to these circuit connections, you need to convert and connect this star connection or delta connection accordingly. Okay. So just I am showing you how this implementing into the circuits. So this is your delta to star conversion. So we know in delta to star conversion, RA is equal to RAB into RAC divided by RAB plus RBC into plus RAC. So we know the resistance, all resistance value are given here. Okay. So accordingly, here we are substituting 20 into 5. Okay. Are you getting this conversion for RA?
Yes.
Okay.
Yes,
For,
sir.
Yes,
Yes,
sir.
sir.
for RA, we can write RAB
Yes,
into
sir.
RAC divided by RAB plus RBC plus RAC. For RB, RAB into RBC. So whatever resistor connected with A, whatever resistor connected with B, whatever resistor connected with C, we are doing multiplications divided by total resistance. Okay. So with RC, we have 5 and 15 multiplications. Okay, divided by RAB plus RBC into RAC. Okay, so here one mistake is given 15 into 15. Okay, so that is 5 into 15. Okay, this is 5 into 15. Have you found mistake? The answer is
sir.
right. The answer is right,
Yes, sir.
but here
Yes.
Yes, sir.
Yes, sir.
now this answer
Yes, sir.
or this connection we are implementing into the further circuits. Okay, so your circuit becomes like this. So this 2.5, this is 7.5, and this is 1.87. Now your earlier circuit is like this. Okay. Now you are converting into star connections. So it is as you know it is converted into star connections. So your connection becomes like this. This 2.5 RA, this RB 7.5, this is 1.87. Okay. So this dash portion, that is your series connections. So 10 and 5 series connections, 10 and 2.5 series connections, 1.87 and 2 series connections, 7.5 5 series connections. Okay. This is not series connection as B point is given here. Okay. So a circuit becomes like this: 12.5, 15, 3.87, 30. Okay, this 25, 5 and 7.5 are in series. 7.5 and this is 30. Now what we'll do next? Anyone?
These two are in delta form, so we have to
Yes.
convert in star.
So here we have two delta. So just we need to solve only one delta. Okay, don't try to solve both delta. Otherwise, you will not get a proper answer. Just try to solve only one delta, you will get the answer easily. Okay, so this 1, 2, and 3 point is given. So we are solving this delta. So according to that, you need to convert into star. Okay. So your star connection becomes like this. Converting this delta 1 to 3, we are getting 5.97, 1.54, and 1.85. Only in the circuit diagrams, you are already having 37.5 and 30 on opposite side. By converting this 1 to 3, we are getting this type of answer. Are you getting? Just try to solve it. Are you getting this 5.97, 1.54, 1.85?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Just okay, everyone just try to get it. Otherwise,
Yes, sir.
Can you go to previous slide?
yes. Okay, I'm going to the previous slide. Okay. So this is your delta. Now convert into star. So you will be having this 1, 2, 3 resistor. Here we name just 1, 2, 3. Okay. So you can write either RA, RB, RC, or you can write R1, R2, R3 because we already use here RA, RB, RC. So for the further simplification, you can write RA dash, RB dash, RC dash, or you can give other name. Okay. Don't repeat this RA, RB, RC again. Okay. Can I move to the slides? Next slide.
No, sir.
Yes.
Wait.
Okay, just I am giving few seconds. Just see these delta connections and try to get the answer.
Yes, sir.
Okay, so this delta is given like this. So just I am drawing the star like this. One resistor is connected and opposite two resistor, and already two opposite resistor are connected. Okay. So you'll get this type of circuit diagram. So that you also take care how to convert this diagram and how to draw this again to fit or to get this diagram. So suppose if you are making wrong diagram, then you will not get the answer. Okay, so answer is 5.97, 1.54, 1.85. So these are in series. These also are in series up and down. Okay. So we'll get like this 39, 31.85. So this is parallel combinations. Okay. So 5.97, 17.54 in series connections. So this is your RAB, that is equivalent resistance of the circuit, 23.51 ohm. The answer is right or wrong? Hello? Are you getting this answer? Hello?
Yes, sir.
Yes, sir.
Okay, so just I am moving to the another example. Okay, so here two data are given. So already naming is given ABC and DCE. So what we will do here? We will solve both delta or only one delta?
Only one ABC.
One delta.
Only one ABC.
Both
No.
delta.
No,
Both.
here yes, we need to solve both the delta. Then we'll get answer. First we will solve this ABC delta, then this CDE delta. Okay. So for this ABC delta, we have this 2, 4, and 6. So accordingly, this conversion is given here. Okay. So your answer for RA, RB, and RC. So for RA, resistor connect divided by 2 plus 4 plus 6. For this RB, 2 and 6 connected, so 2 into 6. And for RC, 6 into 4, 6 plus 4 plus 2. Okay, so this is 2 by 3, 1 and 2. Okay, are you getting this conversion?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
This is ABC. Now we are moving to the CD. Okay. Now CD 253. So this RC, RE, RD. So for this RC, 2 into 5 divided by 2 plus 5 plus 3. For RE, 5 into 3 divided by 2 plus 5 plus 3. And for RD, 2 into 3 divided by 2 plus 5 plus 3. So that is 1, 3 by 5, 1.5. Now how you are going to implement? So you are going to implement like this. Okay. So this is your star connections and this is your connections. Okay. This 2 by 3, 1, 2. Now 3 by 5, 1.5 and 1. This is your star connections. Okay. And 3.5 is already given. So in diagram you can see 3.5 is given. So delta is arranged. Two resistor is connected and one downward. Then again two resistor on one line and one resistor that is upward. Okay. So that is your star to delta conversion. And 3.5 is already given. So this is series connections. Okay, so this is 3, this 2 by 3, 3.5, 3 and 6. So answer is here, these all are in series connections. Okay, so the answer is current supplied by the battery 49 divided by 49 V by R. So V, that is your 49 by 50 ampere. Okay. So anyone having doubt regarding to this example?
No, sir.
No, sir.
So we will solve more examples for the star delta, so we'll get the idea. Okay. So I will also provide this material. Okay, this PowerPoint presentation. So you can solve from your end, and you will get the full marks in examinations by practicing these examples. By seeing or reading examples, you will not get the answer. Okay, you need to do the practice. Okay, and not necessary that I will ask these similar examples. I will either change the values, or I will also change some circuit connections. Okay. Okay. Now, okay. So we'll in next lecture we will solve some more examples for star delta transformations. So after completing star delta transformations, we will go for mesh and nodal analysis. Okay. Yes, Bansi, any questions?
No, sir.
Okay. If anyone having doubt, then questions. I will also provide one ebook. Okay, that VK Mehta. In VK Mehta, some extra examples are given. Okay, some unsolved examples are also given, so you can solve at your home in your free time. Okay. Okay, so if you are not having any doubt, then you may leave the session.